Okay then. Hello, this is a demonstration of hypothesis testing and the binomial distribution for the MEI S1 spec syllabus, and using June 2014 question 3 as an example. And I'm going to use the method of comparing the critical values here rather than comparing the probabilities. I'm not going to do this first section here, part 1, because that's a general binomial question. So we'll go straight on to the second part. Okay, first thing we do then is read the question. It is known that on average 85% of seeds of a particular variety of tomato will germinate. The next part is about the first year, and he's taken a sample of 15, so we'll ignore that and move straight on to the second part. The following year, the second year, Ramesh finds he still has many seeds left. The seeds are now 1 year old. He suspects that the germination rate will be lower. He conducts a trial by randomly selecting n of these seeds and sowing them. He then carries out a hypothesis test at the 1% significance level to investigate whether he is correct. He's correct in what? That takes us back to the second sentence, whether he's correct that the germination rate will be lower. Keyword there is lower. He could have had higher, could have had lower, he could have had different, but he's gone with lower. Okay, so what's part 2? Ask us, write down suitable null hypotheses and alternate hypotheses. Give a reason for your choice of alternative hypothesis. Okay, so let's start with that. So what's the first thing we do in hypothesis testing is we define our hypotheses, and our starting point is always our known position, the null hypothesis. Can't spell hypothesis, which is known as H0, and we base that on our known position. Now in this binomial testing, we make that it's got to be equal to a situation, so we're having our probability P equals whatever our known probability is, and in this case it was 0.085. We also, for MEI, have to remember to define what that probability is. So P equals the probability that, and what we're looking at here, a seed will germinate. Yeah. Okay, so that's our null hypothesis. Let's try and make that a bit clearer, shall we? Back into their hypothesis. We also have to have an alternate hypothesis, and this is about our unknown position. That's H1. And here, our proposal is he suspects the germination rate will be lower. So we know we've got to use probability again, and we know we've got our 0.85, but we need to decide, and we've got a series of options. It could be greater than, the relationship could be greater than, less than, or not the same as, not equal to. Now in this case, and they've actually asked us here to give a reason for what we're about to do, we're going to assume that the probability is less than 0.85. Why are we doing that? Because we've chosen H1 to be P less than 0.85 because. Why? Because Ramesh suspects that germination rate is lower, therefore it's reduced, yeah, so it's less than, and he also thinks it's lower than normal, and the normal was which is 0.85. So if we put those two bits together, we're going to have the probability that it's less than 0.85. So that's the first part. and for that we're going to get 4 points. We're going to get 1 point for us defining the probability to be P to be the probability that seed will germinate. We get a point for writing our null hypothesis, we get a point for writing our alternate hypothesis, and we get a point for giving a reason. So we're doing pretty well so far here, aren't we? Okay, what's it then ask us to do in part 3? It says in a trial with n equals 20, Ramesh finds 13 seeds germinate. Okay, well that's we've got here, this is we call our test data. This is a test he's carried out and he's got a result. So there's our test data. And then they ask us to carry out the test. Okay, so let's work our way through the next part of this. The next thing we can find out here is how many tails we're looking at. So what do we mean by tails? Which areas are we interested in? Tails. We could have 1 tail or 2 tails, because we might be interested in, for 2 tails, we might be interested in higher or lower probabilities, or 1 tail, it could be just higher or just lower. In this case, we know that we're interested in P being less than 0.85, so we know we're interested in 1 tail, and we know we're interested in the lower P area, yeah, and the lower number of germinations. So that's useful information to us. We then go on and they've talked to us, the next thing we need to look at is our significance level. Significance level. Significance level. And in this case, what did they ask us? Go back up to the question. They told us to carry out the test at a 1% significance level. Okay, so we've got a 1% significance level, and we've got only 1 tail, so all of that 1% is going to be allocated to the lower tail. If it was a 2-tailed test, we'd have to split that up. But here we're only interested in the 1%. Okay, so how can we use that information to find our critical region? Let's start off. I think we've got one more thing to do. Let's have a quick look at our test statistic. Okay. So our test statistic was 13 of 20. So what do we know from that? Well, with the information we had earlier, we know we're using a binomial. We know that the number of trials is 20, and we know that our probability that we were interested in was 0.85. So that's really useful because it's given us our binomial. And from that, we can start looking at our critical values back to our significance level. So how are we going to find, if we're going this route, we want to find our critical values and our critical region. So start off by finding a critical value. In this case, it's only going to be 1 because we've got a 1-tail test. What we're interested in is the value of x such that px equals r, such that our value is the greatest. It's got to be less than our significance level, which was at 1% will be 0.01, but it's got to be our highest value of r. So I'm going to start to draw ourselves a diagram here because I think it will help us. So in this case, we've got a binomial, and with the number of germinations being between 0 and 20. Given the values there of n and p, we know that our expected value, if the world was as we expected, we would have expected to see the expected value formula would be NP. So we'd have expected to see 17 seeds germinate. Okay, just thinking us going. Now what we can do is start looking at compare it, and we've got a test statistic of let's have a look back at our test statistic. Our test statistic, TS, was 13. What we've got to do is work out what our critical region is and our critical value using the binomial distribution that we can create. So we can work our way along, and I'll do one just to demonstrate. So we have to work our way up from the most extreme point. So what's the most extreme value? Well, we could have got no seeds germinating. That would be really extreme, wouldn't it? If we're expecting 17, we got 0. So what we've got to do is what's the probability of that occurring? That's a binomial, we said, of 10, 0.85, and our p-value for that will be x equals 0. Will be the probability we're looking for. So if we go into our calculator, let's use the calculator to work this out. So here we are in our menu for statistics. Then we're going into distributions. Then we're going to binomial. In this case, we only want a single point. So we're going to use BPD for our 0 place. So the first thing I want to do is we're going to use variable data we're going to put in. So our outcome, our number of successes will be 0. The number of trials here will be 20. And the probability of success will be 0.85. So here we can just push the button and we can get our first value. So, and I'm going to make a little table here. So here we had x when the value of r, it was 0. Our probability was incredibly small, wasn't it? 3.3 times 10 to the minus 17. So what we're interested in is a critical a value. The largest value here of that would get us up above or get us to a just below probability of 0.01. So that's really low, isn't it? So let's try another one. Let's try what's the chance of if the value of x was 10? So let's use that next. Now what we do want is we want to be we're looking here for a probability that x is less than or equal to 10, yeah, because we're interested in 10 or more extreme. So we're going to use our BCD function. Let's go up here and go to distributions, binomial, BCD, and here we're going to put our actual successes at 10, and we're just going to press our execute, and here we've still got a very low number, haven't we? We've got 2.48 times 10 to the minus 4. So if we rewrote, so that's still well below 1%, isn't it? 2.48 times 10 to the minus 4. Okay, so let's work our way up. Let's go to 11. So if we use that figure, so we're now going probability x is less than or equal 11. You see how we're working up now towards figure we're interested in. So let's get our calculator up again, and we'll go up and we'll put 11 in. What we got now? 1.3. So I jumped over too quickly. 1.33, 10 to the minus 3. Yep. So we're getting closer now, aren't we? What's the value at 12? I'm doing it this way. I don't have an inverse function on this simulator. 5.9. 5.9 times 10 to the minus 3. 10 to the minus 3. What about 13? Which is our actual result. Test statistics. So if we do that, we should know where we are in the world. 13. Oh, so here we've got 0.0. Let's write it in ordinary form. 22. Are we okay with that? So these figures here, if we just did a column, ask less than 0.01, so they're more extreme than our significance level. So yep, that's more extreme than, that's more extreme than, that's more extreme than, that is, and that one's not. So what's our highest value of x? It's 12. Okay, so go back into our line up here. We would have, that's going to be our critical value. Our critical value is 12. And what's our critical region? Well, our critical region will be further away from our expected. So we'll be going more towards 0. That's more extreme, isn't it? So that's our critical region. And if we had a result in that region, we'd be going with the H1 and be rejecting H0. So, but here we can quite clearly see that our test statistic 13 is not in the critical region. Yeah. So in summarizing that, we can say, let's go. So we're going our test statistic of 13 not in critical region. Yeah, critical region. So what are we saying? We're saying there's no significant evidence, because we're always compared to reject H0. H0. So our H0 is accepted. And if we're saying there's no significant evidence, we're also saying that there's not enough evidence to suggest. These are the words in the MEI like, so you can use suggest, or you could use indicate that. And what were we trying to test in the first place? That germination rate is lower. Okay, you can see what we did. If we go back up here on our diagram, we can see what we were doing. So we created our line. We found where we would expect the outcome to be if the situation was as we predicted in our H0, i.e. 17. We actually got our result of 13 germinations, but to be statistically significant, we needed a result between 0 and 12 germinations. So it was not significant. I think I put no significant. I should be not significant. Not significant evidence. And so our H0 is accepted. We haven't seen any material change. Okay. Finally, here's a quick summary of hypothesis testing for the binomial and the information you need to provide to MEI to get the full marks. So for the first part, we had to define what our probability is here, that the P equals the probability that, in our case, it was that a seed would germinate. We have to define our null hypothesis as a P equals some known value. Then we have to choose our alternative hypothesis. It's either a one-tail or two-tail, and it's one-tail if it's greater than or less than, because we're only interested in one extreme, either high or low, or it's two-tail if we don't care whether it's high or low, it just has to be different. We're going to calculate we've got our test statistic, which is R of n, so that's our 13 of 20 in this case. And in this method, we don't need to do any more than that. We're just going to position our R value, our test statistic, as to whether or not it's in the critical region. In this version, we have to get our significance level of it's either 1% or 5%. We might have to split it if it's a two-tail, otherwise we'll put it all together at the extreme end. And then we have to find our critical value from our binomial. So we're putting in different values of P. So we know our binomial, as we looked at here, is B and P. We know those two values. And we're going to find our value of X. That is the highest value below our significance level. So as close as we can to get to the zero, if it's 1% to 0.01. And finally, we then compare the test statistic, our in this case 13 of 20, so it's our 13, and we identify whether it's in or not in the critical region. If it's in the critical region, then we've got significant, the evidence is significant, and we'd be saying there's enough evidence to suggest or indicate that germination rate has reduced, is lower. But if it's not in the critical region, then it's not significant evidence, and we're saying there's not enough evidence to suggest or indicate that the germination rate is lower. And that's how you do the test, by using our binomial values in the finding whether it's in the critical region. I hope that's of use to you, and best of luck.